For the problems we've done so far in this section, the x value they give you is usually an integer. However, there's some problems that they'll give you where it's not. So in this case, what they're telling you to do is, if you're given a value that's a decimal or not an integer, what they want you to do is they want you to find linearization. Here's our function. But they want you to center your linearization not on the decimal, but they want you to find a nearby integer. By doing that, that's going to make the derivative in the function easier to evaluate because then we're using integers instead of using decimals. So the first thing you want to do on these kind of problems is to pick an integer that's closest to negative 0.9. And what I'm going to use in this one is I'm going to let a equal negative 1. Okay, so a is negative 1, that'll make it easier to evaluate instead of using the decimal. Okay, so once we do that, then we're going to go ahead and proceed, same process that we've done already for the other problems in this section. The first thing you want to find is f of a. A is negative 1, so we're going to find f of negative 1, and of course this makes it a lot easier to evaluate in our polynomial than if we're using decimals. Negative 1 goes into here. 3 times negative 1, that's positive 3, and then I'll get negative 2, so 3 minus 2 is 1. 1 minus 4 is negative 3, so negative 3 is our f of a value. Next, we want to find f prime of a. We need the derivative. We can find the derivative by using the power rule. So f prime of x, let's find the general derivative first. 2 comes down, 6x plus 2. We want to find f prime of a, our a value we said was negative 1. So f prime of negative 1 is going to be, if we put that in there, 6 times negative 1 is negative 6 plus 2, you'll get negative 4. So now I have negative 3 and negative 4, which I can use in here to get the linearization. Okay, so I do L of x is equal to f of a, that's our negative 3, plus f prime of a, our derivative at a is negative 4. So I can make this, let's make it minus 4, and I have x minus a negative 1, which will actually turn that into a plus. So now that I have this, I'm going to multiply that out, combine it together, and write it in slope-intercept form. So L of x is equal to negative 3 minus 4x, and then minus 4. Distribute that into each of those. And then finally we'll write it in slope-intercept form, negative 4x rather, negative 4x, and then minus 7. This would be your final answer. So this is the linearization, and we centered all of it around negative 1. Again, it made the calculations a lot easier to use it with negative 1 instead of using negative 0.9, and this would still give us a close enough accuracy. Our next problem here, we're given a x of o that's a fraction, and our original function is a fraction as well, but we're going to pick a value that makes this easier. We want to center linearization on the closest integer to 11/5. So we know that 11 over 6, if you put that into a calculator and work out the decimal, that's going to be closest to the integer of 2. Okay, because we know that 10 divided by 5 is 2, so if you have 11 over 5, it'll be just slightly larger than 2. So I'm going to pick a is equal to positive 2. And then now I can find my f of a. So f of 2, okay, I have 2x divided by x minus 1. So I have 2 times 2 on top, and then I have 2 minus 1 that's going to go on the bottom. So I get 4 over 1. F of 2 is equal to 4. Next, I want to find the derivative. Now, because I have a division happening here, I have to use the quotient rule. Okay, so f prime of x, I take the quotient rule. So the quotient rule says we take the bottom, which is our g, the bottom thing, x minus 1, times the derivative of the top. The top is 2x. That derivative is 2. Minus the top thing, which is 2x. And then we're going to do the derivative of the bottom. The bottom one is, it's going to be 1 all over the bottom squared. X minus 1 squared. We can do a little cleanup on this. Okay, we can do 2x minus 2 minus 2x, x minus 1 squared. The 2x's are going to cancel out. That's going to leave you with negative 2 over x minus 1 squared. And this right here would be the most simplified version of the derivative. Next thing we want to find is f prime of a. So I want to find f prime of 2. So that's going to be negative 2 over 2 minus 1 squared which is going to be just negative 2 we'll get as a result, because we just get a 1 on the bottom when you work that out. So we've got 4 and negative 2. That's what we're going to be putting into the linearization formula. So let's do that now. Okay, so I have L of x is equal to f of a. F of a is 4 plus f prime of a. The derivative at 2 at our a value, that's negative 2. Okay, so again we'll do minus 2 here. X minus a, we're going to do x minus 2 on the inside there. Let's multiply this out. Remember that multiplication comes before you can do this, so be careful you don't accidentally do that quick and make that 2 by subtracting that. You got to do a multiplication first, so we're going to do minus 2x plus 4. And then when you combine everything together, you get negative 2x plus 8 if you want to put it into slope-intercept form. Okay, we're going to review inverse trig functions in this one, because now they're asking us to work with the inverse tan as far as taking derivatives. Now, let's think about what integer we're going to use. We don't want to use pi over 12. We want to pick something that's close to that. Now, pi is close to about 3, so I'm looking at about 3/4, which is about 0.25, which means that the closest integer value to that is going to be 0. And yes, it is okay to use 0 because it's considered an integer. So we're going to use that in this case. So I want to find f of a first. So I want to find f of 0, which means I want to find the inverse tan of 0. Okay, so the inverse tangent of 0 is going to be 0, because at 0 degrees we have sine over cosine, and we know that sine is 0, so 0 over 1 will give us a 0 there. Okay, so 0 degrees we have for that one. Alright, so that's our first value. Next thing we want to do is find the derivative. Okay, so the derivative, if you have inverse tangent of u, the formula is u primed over 1 plus u squared. In this case, our u is x. So if I use that special formula, so again you want to review the, if it's unfamiliar to you, you want to go back and review the section on derivatives of inverse trig functions. That's the formula that goes along with that. So that would be u primed is 1 over 1 plus u squared. That'll be 1 plus x squared. That's going to be your derivative. We're going to put in a 0 into x. We're going to find f primed of 0 equals 1 over 1 plus 0 squared. That's going to give you a slope of 1. So now these two numbers we can put into here. Okay, so L of x is equal to 0, that's f of a. Okay, and then I have plus 1, and I have x minus 0 on the inside. When you simplify this, your answer is just going to be x, because everything else 0 we don't have to write there. So in that case, that's your linearization. It's going to be L of x equals x.